Hello, beautiful people. Today we'll be covering gravitation by distribution of mass. And in gravitation by distribution of mass, we'll be covering attraction by a pair of particles. What I mean in simple words, consider in a plane like this, you are having a particle here. Let's call it particle C. Then you have a particle here and a particle here. Then let's call this particle P and this particle A. We want to calculate the attraction that this particle C experiences due to particle A and particle P. Let's say particle A is a distance from the origin O, and particle B is a distance from the original O, and particle C is spaced x distance from that axis. So if we take this distance here to be r, obviously this distance here will also be r from BC, and let's say this angle is theta here. What will happen? C will experience a force which is going that way due to point A, and that force, if let's say it's force prime, F prime, we'll say it's equals to G. If we give this particle a mass of m and this one a mass of small m, right, we'll say it will be G mass m, capital M, and this one, let's give it mass of m, capital M, right, m all over r squared. That will be the force that it experienced that goes that way, right? But in reality, C will also experience a force which goes this way, a force due to P which goes this way, right? If you check this force and that force will be equal because they are in the same, they are placed, they have the same distance away from C. But if you check closely with this force, we have this component which goes down here and this component that goes there. We have your angle here, which will be theta, obvious. Then this one will be force sine theta, and this one will be the force cos theta, right? Same applies here. You have this component, you have that component, and since these two forces are equal, it means that all of their components are equal, meaning this component will cancel out with that component, right? We'll only be left with the F component. But we said our F here, which we call it F prime, not just F prime, right? Our F prime, we said it's G M capital M all over M, G capital M small m all over r squared, right? So if you want to find the entire force that C experiences due to A and B, we'll say, let's call it force F. It will be equals to F prime cos theta that it experiences due to A plus F prime cos theta which it experiences due to B. We'll say this is 2 F prime cos theta. F is equals to 2 F prime cos theta. We're still together, eh? But we said our F prime is this much, right? Therefore, we'll say F is equals to 2 GM M all over r squared cos theta. So if we multiply by r, both the denominator and the numerator, will say multiply by r all over r. We get that our F is equals to 2 GM M r cos theta all over r cubed, right? If you go back to our diagram, our diagram, you see this is our r, this is our theta, meaning this line here, it will be r cos theta, but this line is also equals to x, which means our x is equals to r cos theta. Using your Pythagoras theorem, you have your x here, you have this is a right angle here, right? and then this is your opposite side, this is your adjacent side, this is your hypotenuse, meaning your hypotenuse r is equals to the square root of x squared plus a squared. Are we together there? Then if we substitute those two quantities to our formula, we get this. It is we said our f, let's recall our f is equals to, which is 2g m all over r cubed r cos theta, right? But we said r cos theta is equals to x, and r is equals to root that much. Therefore, we'll have our f is equals to 2g m. Instead of writing r cos theta, we write x all over, and then we say x squared plus a squared all over 3 over 2. Okay, this is 3 over 2 right here, right, to the exponent 3 over 2. Now we have x over 2 inside this bracket. If you want to cancel out this x over 2, it means we have to multiply inside this 3 over 2, right? For us to do like that, we can divide the numerator and the denominator by this quantity, which is x squared all to the 3 over 2. Since 3 over 2 is equals to this 3 over 2, this x squared can simply cancel out with this x squared. But if you check using simple maths, this quantity is also equals to, these 2's can cancel, is also equals to x cubed, right? If we divide the numerator by x cubed and divide the denominator by this much, we are just multiplying the entire formula by 1. So what we are going to do, we'll say f is equals to it will be 2g m in brackets, it's x all over x cubed, right, all over, we have it will be x squared all over x squared plus a squared all over x squared all to the power 3 over 2, and that will give us, this is 1, right? That will give us this is 1, and this one, which will be, the x will cancel out, and then here we'll take away 1x and we'll be left with squared. So it will be f is equals to 2g m all over x squared, which is this x squared, multiplied by 1 plus a squared all over x squared to the power negative 3 over 2, right? Notice one thing. If x becomes large, for which x is this distance here, the distance of C from the x's that have a and b, right? If we make x approach infinity, right, this quantity here, a squared all over x squared, will approach 0, right? Meaning we'll be left with 1 plus 0 to the power anything, it will be 1. So we'll only be left with this quantity over here. So when x approaches infinity, the force experienced by C due to A and B is equals to 2, it's approximately 2g capital M small letter m all over x squared. And that's the final answer. Thank you for watching this video. Please don't forget to subscribe and like this video. Comment right below. Thank you very much.